In the silent, eternal ticking of the cosmic clock, our solar system stands as a breathtaking masterpiece of physics and time. Roughly 4.5 billion years ago, a chaotic cloud of interstellar dust and gas began to collapse under its own gravity, swirling into a massive, fiery disk. At the heart of this storm, a star was born, our Sun, while the leftover debris began to clump together, forming the planets, moons, and asteroids we recognize today. Each planet in this solar neighborhood tells a unique story, a saga filled with wonders that often defy human imagination. In this documentary-style journey, we will venture from the blistering heart of our system to the frozen, lonely edges of the Kuiper Belt, exploring the secrets hidden within these celestial bodies. The undisputed heavyweight champion and the very source of life's energy is the Sun. Containing over 99% of the total mass in our solar system, the Sun's gravitational pull is the anchor that keeps every planet, comet, and piece of space dust in a steady, rhythmic orbit. Without this stellar engine, the planets would simply drift off into the dark void of interstellar space. Deep within its core, nuclear fusion releases a staggering amount of light and heat, fueling the biological processes on Earth. While the surface of the Sun crackles at thousands of degrees, its core reaches millions, creating a pressurized environment so intense that atoms are literally crushed together. The solar winds emanating from this giant travel millions of miles into space, shaping the atmospheres and magnetic shields of every world they touch. The closest survivor to this solar furnace is Mercury, the smallest planet in our system and only slightly larger than our moon. Because it lacks a substantial atmosphere to trap heat, Mercury is a world of impossible extremes. During the day, the sun-facing side is roasted by temperatures that could melt lead. Yet during the long nights, that heat vanishes into space, leaving the surface in a deep, bone-chilling freeze. Mercury is a battered world, its face scarred by countless craters from meteorites that have slammed into it over eons. It rotates on its axis with agonizing slowness, yet it zips around the sun faster than any other planet. On Mercury, a single day, from sunrise to sunrise, takes months of Earth time, creating a strange, slow-motion reality in the shadow of the sun. Beyond the scorched plains of Mercury lies Venus, often called Earth's evil twin. At first glance, it shares a similar size and composition to our home, but the similarities end there. Venus is the ultimate cautionary tale of a runaway greenhouse effect. Its atmosphere is a thick, suffocating blanket of carbon dioxide that traps solar heat so effectively that it is actually hotter than Mercury, despite being further away. The surface pressure is equivalent to being half a mile underwater on Earth, enough to crush a submarine. To make matters worse, the yellowish clouds that shroud the planet rain sulfuric acid, and the landscape is dotted with thousands of volcanoes. It is a world of perpetual gloom and crushing heat, a hellish landscape where no life as we know it could ever survive. Then we find the jewel of the solar system, Earth. Situated in the Goldilocks zone, our planet is at just the right distance from the sun to allow water to exist in liquid form, a fundamental requirement for life. Earth is a vibrant blue and green sanctuary, protected by a complex atmosphere of oxygen and nitrogen, and a powerful magnetic field that deflects harmful solar radiation. Our planet's tilt and rotation create the seasons and the day-night cycles that drive global weather patterns. Our moon, the only natural satellite we have, plays a critical role in stabilizing Earth's tilt and creating the tides that have shaped our coastlines and biological evolution for millions of years. Earth remains the only place in the vastness of space where we have found the miracle of consciousness. Neighboring Earth is the rusted frontier of Mars, the red planet. Mars has captivated human imagination for centuries, primarily because it is the most habitable-looking world beyond our own. Its iconic red hue comes from iron oxide, essentially rust,
covering its dusty surface. Mars is a land of superlatives. It hosts Olympus Mons, the largest volcano in the solar system, that stands nearly 3 times the height of Mount Everest. It also features Valles Marineris, a canyon system so vast it would stretch from New York to Los Angeles. While Mars is currently a cold, dry desert with a thin atmosphere, evidence suggests that billions of years ago it was home to massive rivers and perhaps even oceans. Today, a fleet of robotic rovers roams its surface, searching for signs of ancient microbial life and paving the way for the first human explorers. Beyond the orbit of Mars lies the asteroid belt, a sprawling ring of rocky debris that never quite managed to form a planet. Past this boundary, the solar system changes dramatically as we enter the realm of the gas giants. The first of these is Jupiter, a colossus so large that all the other planets in the solar system could fit inside it twice over. Jupiter is a swirling world of hydrogen and helium with no solid surface to stand on. Its most famous feature is the Great Red Spot, a massive storm larger than Earth that has been raging for at least 300 years. Jupiter acts as a cosmic vacuum cleaner, its immense gravity pulling in or reflecting dangerous comets and asteroids that might otherwise strike the inner planets. Among its dozens of moons, Europa stands out as a prime candidate for life, with a hidden saltwater ocean buried beneath a thick crust of ice. Continuing our outward journey, we encounter Saturn, the crown jewel of our solar system. While other planets have rings, none are as spectacular or complex as Saturn's. These rings are composed of trillions of pieces of water ice and rock, ranging in size from specks of dust to the size of mountains. Saturn is so low in density that if you could find a bathtub large enough, the planet would actually float on water. Its largest moon, Titan, is a world of its own, boasting a thick, nitrogen-rich atmosphere and stable lakes of liquid methane and ethane on its surface. Titan is often described as a prehistoric version of Earth kept in a deep freeze, offering scientists a laboratory to study the chemical origins of life. The outer reaches of our system are home to the ice giants, Uranus and Neptune. Uranus is a true oddball. Unlike the other planets, it rotates on its side, likely the result of a massive collision billions of years ago. This extreme tilt means its poles experience decades of continuous sunlight, followed by decades of total darkness. Both Uranus and Neptune get their deep blue and cyan colors from methane in their atmosphere. Neptune, the furthest major planet from the Sun, is a world of terrifying weather. It has the fastest winds in the solar system, whipping around nearly 1,200 miles per hour. Its moon, Triton, is equally strange, orbiting the planet in the opposite direction of Neptune's rotation, suggesting it once was a stray object captured by Neptune's powerful gravity. Beyond the orbit of Neptune lies the Kuiper Belt, a dark, icy graveyard of frozen objects and dwarf planets like Pluto. Pluto was once considered our 9th planet, but it is now recognized as one of many small, icy worlds that dwell in this cold frontier. Even further out, far beyond the reach of our most powerful telescopes, lies the Oort cloud, a theoretical shell of trillions of icy bodies that marks the very edge of the Sun's gravitational influence. This is the birthplace of long-period comets that occasionally visit our inner solar system. When we look at the solar system as a whole, we see a vast, interconnected web of gravity and light, a testament to the laws of physics operating on a grand scale. Our solar system is a sanctuary of diversity and wonder. From the blazing heart of the Sun to the cryogenic silence of the outer rim, every planet and moon offers a different piece of the cosmic puzzle. As we continue to launch probes and plan for human missions to other worlds, we are learning that we are part of something much larger than ourselves. Yet for all our exploration, the most profound realization is the fragility and uniqueness of our own Earth. In the vast, cold void of space, our pale blue dot is a rare haven that we must protect. Our journey among the stars has only just begun, and the universe still holds countless mysteries waiting for the next generation of explorers.